Density and graphing tests. Density of different materials have blank densities. They must have different densities. Keyword, different materials. Water has a density of, remember the lab, 1.0 grams per milliliter. A student has a sample of aluminum and calculates the density to be 2.7 grams per centimeters cubed. What does he have? Aluminum. If he cuts the aluminum into 4 equal pieces, what will the density of each piece be? Well, if he cuts the aluminum, does he get anything different? No, it's still aluminum. It's just smaller. The molecules do not rearrange, they stay the same. So when you cut something, what happens to the density? Think back to the wood lab. Did the density of wood get 4 times smaller when we had different pieces? No, it stayed the same. Most of you got this question wrong, even though you did well in the lab. Go figure. All right, let's go to the next page. All right, this page shows us a graph. The graph below shows a runner's distance from the starting line in a 30-minute race. Identify the responding dependent variable in the graph. Well, if you attacked your graph like you were told to, mix and dry, this piece was very simple. Your dependent responding variable, RD, is on the y-axis, so it should have been distance in meters. What's the relationship between time and distance in the graph? Look on your graph. What's happening to the time? The time is increasing, 0, 10, 20, 30. What's happening to the meters? Oh, they're going up as well. So the answer must have been, as the time increased, the distance increased. Okay, let's go to the next question. What is the volume of the rock in the diagram below? Many of you asked me to show you where the water line was. The water line is here at 30. That's the original water. Then you put the rock in and the water line goes up to 40. So how much water did the rock displace? What was the volume of the rock? What do you do to these two numbers? You need to subtract. And when you subtract the 40 and the 30, you get 10 milliliters. The next question made me laugh because many of you did such beautiful work when you showed me the volume formula, length times width times height. You substituted beautifully. Then you picked the wrong answer because you're knuckleheads. You didn't read all the choices. You picked the first one, but neglected to realize that was missing something. So please read carefully because you made a silly error. And I think some of you already know that this was a silly error. No naked numbers. Okay, next question. Density of common liquids. Look, use the table below to answer questions 8 through 9. Gasoline has a density of 0.7 grams per milliliter. What will happen when it's mixed with water? Well, you know the density of water is 1. So when water is in the cup and you add gasoline, will it sink or will it float? It's not going to change its mind, float then sink or sink then float. These are silly. So right away you should have gotten rid of those. So the density of water is greater than the density of gasoline. So therefore the gasoline has no choice but to float. This liquid will float above water, but it will sink below gasoline. So we already drew ours. So right now we have gasoline here and water here. Which one will float above the water but sink below the gasoline? The number must be in between, and the only choice would be alcohol. So far, so good. Let's keep going. Use the table below and the table above. Well, the table on the next page. To answer questions 10 through 12. This is the only substance that will sink in mercury. Let's go back and see what mercury is. Mercury has a density of 13 and 6/10. This is the only thing that will sink in mercury, so it must be greater than mercury. Has to be gold. This is the only solid substance listed below that will float in all the liquids on the other page. So let's look at all the liquids. The smallest density is 0.7. So what's going to float in 0.7? The only thing could be cork. And this will float in water but sink in gasoline. Once again, water is 1, gasoline is in 7. So which one is going to float in water but sink in gasoline? It would have to be in between water and gasoline, which could only be ice. 0.92 is going to float. You know your ice cubes float in your water. All right, the lines on the graph show the relationship between volume and mass for liquids A, B, and C. Which one has the greatest density? Remember the pennies in the Nichols lab? Remember you had um, the greatest mass was the Nichols, and it had the highest line? Same thing. Greatest density would be letter A. It has the steepest slope. And as the volume of each liquid increases, what happens to the mass? It also increases. Look at your lines. It's a direct relationship. All right. Use the following questions. Show all the work to get full credit. Density, because we love density. You could have put your little heart there. Cut in half. Substitute. What is the mass? 200 grams. No naked numbers. What is the volume? 25 centimeters cubed. Mass, volume. You write your formula, and then you substitute. Density is mass divided by volume. Then you divide. The top number goes in the calculator first, then the bottom number, and you get 8.0 grams per centimeters cubed. Now, some of you had a number that was less than 1. Look at this number. Use your common sense. 200 over 25. Could it be less than 1? That is obviously more than 1. So sometimes you got to step back and say, okay, let me look and make sure I did this right. Otherwise, let me rethink this. This number goes in the calculator first. Don't forget. Because this line right here is telling you divided by. 200 divided by 25. So the answer is 8 and 0/10 grams per centimeters cubed. Ha! Some of you, a lot of you, forgot the 0 and you lost a point. Shame on you. All right. This one is substance B. The mass is 12 and the volume is 24. Density formula doesn't change. Mass over volume. You got a point for that. You substitute. Instead of mass or M, we put 12 grams. Instead of V, we put 24 and 0/10 centimeters cubed. What number goes in the calculator first? You are right. The number on the top goes in the calculator first. 12 divided by 24, 0 and 5/10 grams per centimeters cubed. You could see this, 12 over 24, that's like half. So make sure your answers make sense. Now we put them in the cup. So what happens? So many of you knew, oh, you drew it beautifully over here, but you drew the wrong thing. Letter A was 8, not 8/10. You changed it to 8/10. So that made me laugh because you had it floating. But it's 8, so it sinks all the way to the bottom. And letter B is in the middle. 5/10 on top, 5/10 on the bottom. So many of you drew that beautifully, except you kind of got silly over here. So check. Make sure you have this correct on your paper. All right, let's go with our graph. This is your graph, and they're asking you to label the x and the y-axis. There's nothing here. So attack your data table again. Mix and dry with an x and a y. Where does the mix go? It always goes on the bottom. Starting from the bottom, now we're here, right here. You're writing elevation in kilograms. Make sure you have the, kilometers. And then your dry is going to be air temperature. You have to use your labels. Degrees Fahrenheit. What is the relationship between elevation and air temperature? You can't answer that until you actually plot your points. So 0 and 85. 0, 85. Oh my goodness. How many of you put dots and got points taken off because you don't read the directions? What does that say? Use an X to plot each point. Exactly. All right, keep going. What's next? Second one. 2 and 75. Go over and up. Put your X. 4 and 60. Over to 4, up to 60, make an X. 8 and 35, over to 8, up to 35, and make an X. 10 and 20, over to 10, up to 20, make an X. Then the next direction tells you to connect with a line. If you didn't connect with a line, you got points taken off as well. You can't just leave it hanging. It's sad. You didn't follow directions. Connect the X with a line. Now they want you to make a title. Label your graph with an appropriate title. Well, what are the effects? The effects of elevation on air temperature. What is the relationship between elevation and air temperature? These are good titles. You know, these are in your notes. You need to study your notes. The effects of elevation on air temperature. If you did not have both of these variables in your title, you didn't get credit. So some of you guys, all it is a matter of looking over your notes. Now, we see this graph, it's going down. So what does that tell us? As the elevation does what? The elevation numbers are going up from 0 to 10. As the elevation increases, the air temperature decreases. What type of graph is that? Is it a direct, indirect, stable, or cyclic? It's going to be indirect because it's going down. All right, that concludes your graphing density test. Have a good day.